of projectile. Okay, let me show you. If this is the projectile, let me just set my screen first. I think it's better now. Yeah, perfectly fine. So let us say if this is a projectile, and which is fired with initial velocity u, right? This is the initial velocity u, right? And the projectile will follow a trajectory like this. It will attain a some maximum height over here, right? This is the maximum height from this point. This is the maximum height, and after that it start coming downward, and this will reach to the ground like this. Okay, so this is the trajectory. That means A, B, C, which is followed by the projectile, right? So for this projectile, if it is fired at an angle theta from the horizontal, right, then what is the range, time period? What is the time period of this projectile? What is the maximum height which is attained by the projectile? And what is the range? As I said, range, that means maximum horizontal displacement from A to C. What is the value of range? This we are going to derive now, right? So as I said, this projectile is fired with initial velocity u, right? So this u is if u is the initial velocity, okay, I'm just taking the components of it over here, okay, and if theta is this angle, then you can see the component which will act downward or horizontal is u cos theta. U cos theta is the horizontal component of this initial velocity of projectile, and the component which will be acting in upward or vertical direction is u sin theta, right? So these are the two components which are broken from this initial velocity, right? So u is broken into two parts, u cos theta, u sin theta, right? So u sin theta will be acting upward, okay, and u cos theta will be acting horizontally. This is u cos theta here, this one, and here it's u sin theta. And students, you know that for attaining the maximum height, this is going upward. So this is the vertical displacement. Here you can see. So maximum height is attained over here. And what is the property of a projectile when it attains a height of b? That means the maximum height at this point. At this point, the vertical component of the velocity will be 0, right? Here the vertical velocity, final vertical velocity is equal to 0 at point B, right? Now what we will do? Taking vertical components, right? Now the vertical, v equal to u plus at, right? So the final vertical velocity, let's write it vy. This is 0 because when the projectile is fired and when it attains a maximum height b, right, from there it starts falling down because it is not going beyond or above b, right? So the vertical final velocity is 0, right? I hope you understand it. Now this v equal to, we are using the formula v equal to u plus at, right? So if v is 0 and u is, what is the vertical component of the initial velocity, that is u sin theta. So just put it in place of u sin theta, right? U sin theta plus at. And what is the value of a? Since the g is acting downward, acceleration due to gravity is acting downward, a is against a is acting against the vertical motion of the projectile. So the value of a will be minus g, right? So the value of a will be minus g into t. Now from here we get the value of t. The value of t is calculated as u sin theta, gt will be coming left side, so equal to gt, or we can say t equal to u sin theta by g, right? So students, the time period of the projectile from A to B is calculated as u sin theta by z. So time period from A to B is u sin theta by g, and from B to C again the same time will be required, that means u sin theta by g. And when you add both these times, you will get the time period of the projectile t as u sin theta by g, which will be coming 2 times. So this is the time period of projectile 2u sin theta by g, right students? So we have derived the time period of the projectile from A to C, that is the total time period, right? That is the total time. A from traveling from A to C, the projectile will take a time of 2u sin theta by g. Now, do one thing. You need to calculate the, let's say this is P, PB. What is PB? PB is the maximum height. PB is the maximum height attained by the projectile. So the maximum height attained by the projectile, watch this. This is the displacement. This is the displacement when you are considering the vertical velocity. So just put up the formula, use the formula S equal to ut plus half ATA square. So the S will be here, the maximum height, this PB or BP. So in place of S, we are writing maximum height, which is, because this is S, this S is the maximum height. This is equal to ut plus half ATA square. So ut you are knowing, u is u sin theta, the vertical component, initial vertical component, u sin theta into t. T, this is a small t, mind it. That means the time taken from A to B. This is u sin theta by g you will be taking. So u sin theta by g plus half ATA square. Since A is acting against the vertical motion and acting downward, so the A will be minus, right? So minus g by 2, A will be g and 1 by 2 will be like this. Minus g by 2 into t square. What is the value of t square? It's u sin theta. U sin theta by g. So u sin theta by g whole square, right? So from here we are getting u square sin square theta by g minus g into u square sin square theta by g square, right? So here 1g and this square will be cancelled out, and we are left with u² sin² theta by g, and we are calculating the maximum height, students. u² sin² theta by g minus, so 2 is also there, minus u² sin² theta by 2g. So when you bring u² sin² theta by g as common, is 1 minus 1 by 2. So u² sin² theta by 2g. So this is the maximum height attained by the projectile. The maximum height attained by the projectile is u² sin² theta by 2g. So students, in this way we have derived the maximum height. Now when we are going to calculate, so we have calculated the time period 2u sin theta by g, this is calculated. We have calculated the maximum height, the second part, this one is also calculated. Now the range is known, range is required to be calculated. So the range is from time, the range is the distance from A to C. Basically it's displacement A to C. So for range, what we will do, let us see. For range, the component of velocity which will be acting is only the horizontal component, that is u cos theta, right? So for the horizontal component of velocity, this one, displacement will be this one, right? Now the range, for the range of the projectile, for the range of the projectile, the initial velocity is u cos theta, right? Initial velocity is u cos theta, right? So the range, the total displacement A to C is equal to range. So that means that is calculated, we know that velocity equal to displacement by time, right? So the velocity is u cos theta. So u cos theta into time. What is the time period of this projectile? This is u sin theta by g plus u sin theta by g. That is 2u sin theta by g that we have calculated over here. So this will be multiplied by this time. So 2u sin theta by g, right? So this will give you the range, right? And when you will calculate it, you are getting 2u sin theta cos theta by g. So basically when you bring u by g as common or outside of this bracket, then inside bracket we can write 2 sin theta cos theta. And you know the formula of 2 sin theta cos theta, it's basically 2 sin theta cos theta is basically sin 2 theta, right? Sin 2 theta. So here u cos theta and u, so 2u are there, so it will be u². So I have missed one of the u, so it is basically 2u² sin theta cos theta, and u² by g is taking common. Inside we are left with 2 sin theta cos theta. So u² by g into sin theta is the range of that projectile which we have considered. That means the distance from A to C, this is u² sin 2 theta by g, u² sin 2 theta by g. So u² sin 2 theta by g is the range of the projectile from A to C. So here we have solved it. Right, students? I think you understand the derivation, how we are arriving and calculating the time period of a projectile, maximum height of a projectile, the range of the projectile is also calculated. What we did, we simply break this component of initial velocity into two components, horizontal and vertical. Here you can see, right? These two vectors, the vertical vector and the horizontal vector, is broken down. We consider the vertical velocity. We consider the vertical velocity in considering or calculating the maximum height of that projectile which is attained, that is P to B. And for that, what we did, we know that V equal to U plus AT, right? Since at this point the vertical component of the velocity, that is final vertical velocity, is 0, so we put Vy as 0 and equated with U plus AT, and in place of U it will be vertical initial component, that is U sin theta. Initial velocity is vertical component, that is U sin theta, this one, U sin theta plus gt. Since gravitational acceleration due to gravity is acting downward, so upward for the vertical movement, g will be acting in the negative direction, minus g, right? So minus g into t. So from this we get t as u sin theta by g. So u sin theta by g is the time taken for the projectile for traveling from A to B. Only half of this, only half of this. And definitely if this is the half time, then for traveling from B to C, it will take again u sin theta by g, this one. And when you will add both the time periods, you will get t as the complete time period of this projectile from A to C as 2u sin theta by g, because both these times have been added. So this is the total time period of the projectile, 2u sin theta by g. Now this is the time period we have calculated, the first part, the maximum height. For the maximum height, again the same vertical component of the initial velocity is required. So we use the formula s equal to ut plus half ata square. Here in place of s, that is the displacement will be equal to bp, that is the vertical height attained by the maximum height attained by this projectile. So this is the maximum height. So this will be equal to ut plus half ata square. Here the time period, that is the only u sin theta by g is the time which will be considered for this projectile for going from A to B, because this is the half of the total time period. So we put the value of small t as u sin theta by g, and in place of u we put u sin theta and minus g by 2, that is half gt square, right? In this way we calculated the maximum height as u square sin square theta by 2g. Now the last part of, so this second part is also resolved, calculated and derived. Now the last part, the range. For the range, we have considered the initial velocity u cos theta, because for the horizontal component of the velocity is only responsible for covering from A to C, right? So initial velocity is u cos theta, and range, we know the velocity is displacement by time, and for velocity u cos theta into time we get the displacement, right? Here mind it, the time will be the complete time period of this projectile. The complete time period is this plus this is the total time period, u sin theta plus this will give you the total time period, mind it. So we'll put to the value of capital T, that means the total time period of the projectile over here, right? And this will multiplied with velocity u cos theta to give you the range. So range is calculated as u square by g sin 2 theta, right? Or u square sin 2 theta by g. So here we have seen how to derive the different formulas of time period of a projectile, maximum height attained by the projectile, and the range of the projectile. I hope you like the session, students, and I think you got your doubts cleared, and how to derive the, not to just remember the formulas of the projectile in solving any numericals, okay? Just whatever the velocity you are giving, the initial velocity, just break it into two parts and apply these equations, v equal to u plus at s equal to ut plus half at square, and just put up the value, you are getting the answers, right? But mind it, from A to B, the time which you have derived u sin theta by g, that is the half of the time required by the projectile to attain the maximum height. And after that, mind it, the projectile will go like this and it will start downfall. And from B to C, it will take another time period of u sin theta by g. So u sin theta by g upward, right, and u sin theta by g is the downward. These are two times, these both are added together to give you the complete time period, right, complete time period. So that you are, that you have arrived to u sin theta by g, right? So just keep it in your mind, the total time period will be 2u sin theta by g, and for half of the travel time of this projectile will be u sin theta by g, right? And when you consider this time period, you will get the maximum range, because from A to C you have covered. So definitely the up time is also considered and the down time is also considered. Then only you are able to reach from A to C. Projectile is fired from point A, it will reach to B. It will acquire u sin theta by g, and from B to C it will again acquire the same time. So total time is considered for calculating the range, but for calculating the maximum height, only the half of the time period is calculated, right? Students, I hope you like this session. Just like and subscribe. Bye bye, take care, thank you so much, bye bye.